Momentum is a big idea, huge idea. We looked at energy, a big idea in physics. We looked at forces. Momentum is another big idea. And what's cool about momentum is it actually ties together energy and Newton's laws. So it's an even bigger idea. Okay, you already know what momentum is. It's the idea that when something's moving, what does it naturally want to do? Keep moving. Okay, it's a consequence of Newton's first law. An object at rest will stay at rest, and an object in motion will what? Stay in motion, right? And so in physics, momentum we define very specifically. Sir Isaac Newton broke it down as follows. Momentum is a product of an object's mass times its velocity. And unfortunately, we run out of letters, okay? We should use M for momentum, but M is already for what? For mass. Therefore, we pick the letter P. Or actually, Newton picked that, so that's what we use, okay? P equals mv is for momentum. Note that in most physics books, P and V either have a little arrow on top or they're in boldface to represent the idea that it's a vector. It has both size and direction. You can have a forwards momentum or a backwards momentum, okay? So in a second, what's with the dorky fake karate kid thingy? Yeah, I actually have no martial arts training whatsoever other than I watched too many Jackie Chan, Bruce Lee, Jet Li movies when I was a kid, and I look Asian, right? But we're going to demonstrate momentum big time by breaking a 1-inch board, no tricks here, with your bare hands, okay? The trick is, though, you don't want to mess up, because if you chicken out, that can be very bad, okay? If your momentum transfer is not complete to the board, Newton's third law, every action there's a reaction force. You could bruise your hand a little bit, or if you whiff and you hit your wrist bone, that could be bad. You wouldn't break it, but you'd bruise it. Well, you could break it if you totally whiff. Don't do that, okay? So anyhow, how do you change momentum? Real easy, okay? Usually the mass doesn't change unless like something bad happens, like you're driving and part of your car falls off. Or when we go to Great America, I always get worried, and there's always some kid who does this. Like at 10 in the morning, they get one of those big turkey legs I'm talking about. Like at 10 in the morning, I'm like, really? And we're standing in line for the Raging Bull, and I'm like, yeah, I'm so not getting on the ride behind you, right? Because you might lose your cookies there. So really, all it is if velocity changes, usually that's when momentum changes. So changing velocity results in a change in momentum, and the way we denote that, you guys remember what this triangle stands for? It's the Greek letter delta. It just stands for change. And change in momentum is equal to delta P equals m delta V, the change in velocity. Okay? Units for momentum. The metric units, SI is for System International. The metric units, very simple. Mass is always in what? Kilograms, and velocity is in meters per second. So the units are kind of weird. It's a kilogram meter per second momentum change. Okay? In the future, as things get more high-tech and we start to have more GPS sensors on athletes and whatever, this might not be that weird anymore. We're literally doing like a football game, baseball game, hockey game, whatever. Coaches will have real-time data on momentum transfer, bam, check against the boards, a penalty, hit, etc. there, okay? Next, moving on, Newton's laws and momentum to tie together, okay? What's cool is momentum encompasses all three of Newton's laws. Newton's first law, the law of inertia, its momentum is inertia in motion. Newton's second law, F equals ma, deceptively simple. Why? It looks like something that you could study in like 6th grade or whatever, right? But really, you could study this all the way through the graduate PhD level. This is a net force, the sum of all forces in all directions. We did it in 2 dimensions. Remember? Forces in the x and y. You could do it in x, y, and z and throw in some calculus while you're at it. Yee! Okay? Acceleration is your rate of change of a rate of change. It's meters per second or meters per second squared. It's how fast you change, how fast you're going. Your change in velocity with respect to time. So it's very powerful, okay? But anyhow, if we substitute in the definition of acceleration your change in velocity with respect to time, which is the second derivative of motion, dx dt is velocity, so the second derivative would be acceleration. But anyhow, if we rearrange this, you get F equals m delta V divided by t. Bring time to the other side, you get momentum, change in momentum. Aha. So in other words, to change an object's momentum, it's very simple. If I have, let's say, here we go, a raw egg flying at you, right? Yeah? How do you change an egg's momentum if it's flying at you? You got to put a what on it? A force on it over a certain period of what? Time, right? Okay? So force over time is equal to mass times change in velocity. Okay? So if you want to change something's momentum, it has no momentum, it's sitting there, you got to put a force on it for a certain period of time. Okay? That's an important idea. We even give it a special name. It is called impulse. Okay? This is a big idea. So momentum, P is equal to mass times velocity. If you change its momentum, delta P, m delta V, we call that impulse, force times time. Okay? The impulse is a product of a net force exerted over a certain interval of time to cause a change in momentum on an object. Ft equals m delta v. Okay, so in fact, when we smash the boards to get you guys psyched up and all that, we'll write out the impulse momentum equation, Ft m delta v. I'll have you sign off, and then we'll smash it, and then you could put it on your desk there. Don't mess with me there, okay? So a lot of fun there. So in the end, if you look at the units here, the units for force is in what? You guys remember? In newtons, in honor of Sir Isaac Newton. Time is in seconds. So a Newton second is equal to a kilogram meter per second. Okay? So some of physics, it's like just learning a foreign language. You got to learn the vocabulary and the units. It's kind of weird. You're not used to Newton seconds, kilograms, meters per second, chicken, fish, cow. Like, what is that? So it's getting used to the vocabulary. Si habla español, parlez-vous français, guten tag, nerdioso. Okay, we're speaking physics here. Got it? So in real life, you take advantage of this impulse idea all the time. So let's go back to the pitching example here, okay? What does a baseball pitcher do to maximize the momentum transfer to the ball? What are baseball pitchers famous for? They always do wind up and wide. Oh, there you go. I have no pitching form whatsoever, okay? So if you think about it, you want to put a little force on the ball or a big force? Huge force, right? You want to pitch the ball at 120 miles an hour or whatever, right? And then do you want to exert that force for just a short period of time? Or as long as time as possible? What do pitchers always do? They do what? They wind up and then they follow through there, right? Huge force over a long period of time gives you huge momentum transfer. You see that? Got it? Same thing in tennis, volleyball, baseball, pitching and batting, you name it, okay? So if you think about it, a lot of times in sports, you're trying to increase momentum. And how do you do that? Big impulse, big force, big time. Whether it's hitting a home run, smashing a tennis ball, etc. So maybe tennis is another good example, right? Usually, unless you're trying to do some kind of weird volley hit because you're charging net, right? During a serve, right? You want a little force on your serve or a huge force? There you go, right? Obviously, what? Huge force, right? And then you just kind of, like a short period of time interval, or do you want to follow through as long as time as possible? Which one? Obviously, right? Longest time as possible, right? How about a gun? When you shoot a gun, right? What goes faster, a little handgun or a sniper's rifle where you can shoot somebody like 3 miles away? Crazy, right? Obviously, that long rifle gives you a bigger momentum change because when the gunpowder explodes, it can accelerate that bullet for a long period of time. If the barrel's like 10 times longer than a handgun, it's 10 times the time transfer for that force there. You'll get, theoretically, 10 times the momentum transfer, 10 times the velocity, right? Which is why rifle bullets are usually supersonic, faster than the speed of sound. The opposite would be decreasing momentum, okay? Like catching a football, jumping on a trampoline, etc. We shouldn't do this, but we'll try this. This was a spontaneous idea. We're going to play a little egg catch there.